Hello everyone, welcome to Dr. D. Patil Vidyapith Center for Online Learning. I am Professor Anand, course coordinator for this course, that is Performing Analytics with Python. Learners, in this session we are going to learn about unit number 1, that is Python Fundamentals for Data Analytics. Before we start, let us have a look at the agenda for this session. In this session we are going to cover about Python data structures and data types, operators in Python, event driven programming concepts, local and global variable concepts, buttons and canvas fields, static drawing and timers, control statements and functions, OOPS concepts, exception handling and file handling. Let us start with the first topic of this session, that is Python data structures and data types. So basically you will find 4 types of data types in Python, that is list, set, tuples and dictionaries. Let us visit them one by one. First, list. List is defined as an ordered collection of items, and it is one of the essential data structures when we are using Python for creating a project or for writing a program. A simple list can be created with the use of following syntax. List name is equal to, in the square bracket, specify the name of the list separated by comma, as you can see in the slide, that is list underscore a is equal to, in the square bracket, list, that is item 1 comma item 2 comma item 3 comma and so on. Second, set. Set is an unordered collection of unique items. Sets are employed when an object's existence in a collection is more significant, is more important than its frequency or the order. Sample set can be created with the use of following syntax, that is name of the set is equal to, again in the curly bracket specify the name of the items separated by the comma. The difference between set and list is that set is an unordered collection of unique items, whereas list is an ordered collection of items. So in case of list there can be duplicate values, but in case of set we cannot have duplicate values. Even if you insert duplicate values, then the system will automatically remove the duplicate values. So the main difference between set and list is that set is an ordered collection of items where duplicate items can be inserted, but whereas set is an unordered collection of unique items. Means what? In case of set we cannot insert duplicate values, and again it is unordered list of items. So this is the basic difference between list and set. Next is a tuples. A tuple is a built-in data structure or built-in data types in Python, that is an ordered collection of objects like sets, but tuples comes with the limited functionality. That is the primary difference between list and tuple is mutability. Means what? Lists are mutable. Means what? I can change the values in the list, I can edit the values of list, but whereas the values of tuples cannot be changed. So tuples are immutable, whereas list is very much mutable. Means what? The items in the list can be changed, whereas the items in the tuples cannot be changed, as tuples are immutable. So a tuple can be created by using the following syntax, that is name of the tuple is equal to, in a rounded bracket, name of the items separated by a comma operator, as you can see in the following slide, that is tuple underscore a is the name of the tuple is equal to, in a rounded bracket, the name of the item, that is item 1 comma item 2 comma item 3 comma and so on. So end with a rounded bracket. So this is how we can create a tuple. Next data type is the dictionaries. Dictionaries are used to store data values in terms of key and value, in terms of key and value pairs. A dictionary is a collection which is ordered and which is changeable and do not allow duplicate values. Dictionaries are written with curly brackets and have keys and values. So, if you want to store the values in terms of key and value, so for that we can use dictionaries. So, a dictionary can be created with following syntax, that is, name of the dictionary is equal to, in the curly bracket, specify the key colon its associated value, comma, again you can specify another key colon and specify its associated values. So, remember that if you want to store the values in terms of key and value, we have to use dictionaries. Now, let us see what are the operators available in Python. So, basically, in order to perform arithmetic, we have arithmetic operators. In order to perform the comparison, we have comparison operators. In order to assign a value to a variable, we have to use the assignment operator. If you want to combine multiple statements and if you want to check for that, then we can use the logical operators. And again, in case of Python, we have two more special operators, that is identity operator and membership operators as well. And again, you will find bitwise operators as well in case of a Python programming language. So, these are the basic operators that you find in Python. Operators basically operates on operands. So, we have binary operators, we have ternary operators in case of Python as well. Let us see first, that is arithmetic operators. So, if you want to perform addition, we can use the plus operator. If you want to perform subtraction, we can use the minus operator. In the same way, for multiplication, we can make use of the asterisk operator. If you want to perform division, we have the backslash, forward slash. If you want to perform the modulus operation, we have the modulus operator. In the same way, if you want to perform exponential operation, we have to use the double asterisk sign, and again if you want to perform floor division, we have double forward slash as well. So, these are the arithmetic operators which are basically used to perform basic arithmetic operations like addition, multiplication, division, subtraction, floor division, etc. Now, come to the assignment operators. The function, the main task of assignment operator is to assign the value to a variable. So, we can see in the slide that operators, example and the compound operator as well. So, in the first column you can see the is equal to sign which is used to assign the value to a variable, and again you can see the operator, that is plus is equal to, it is same as x is equal to x plus 3. If I write x plus is equal to 3, I can also write as x is equal to x plus 3. So, the plus is equal to is called as the compound addition, compound assignment or compound if you want to use the shortcut, instead of writing x is equal to x plus 3, I can write x plus is equal to 3, which is same as x is equal to x plus 3. In the same way, if I have to perform multiplication, if I have to write like x is equal to x multiplied by 3, I can write x multiplication symbol equals to 3. So, in this way also I can make use of compound assignment. So, it is up to you what kind of operator, what kind of assignment operator that you want to use. So, these are the assignment operators, all the operators, that is from the assignment is equal to plus, subtraction, addition, multiplication, floor division, exponentiation. For all these operators we can have also its associated compound assignment operators. Now let us look at the comparison operator. The comparison operators are used to compare two variables for equality, non-equality, greater than or less than. So for example, operator is equal to is used to perform whether two variables are having the same value or not, that is x is equal to y. If it is, then it returns a Boolean value, that is either true or false. So always remember that the output of comparison operators is always a Boolean value, either it will give you a true value or a false. True value means that is greater than 0. So greater than 0 is always true and 0 is always false. So the output of all comparison operator statement is a Boolean value, either true or false. That is, if x is equal to y, so if x and y are having the same value, then it will give you true, otherwise it will give you a false value. So in the same way, if you want to perform not equal to, that whether a value, whether a variable is not equal to the other variable, so in that case I can use the not equal to operator to check for non-equality. In the same way, if you want to check whether a number is greater than, then I can use the greater than operator. For less than, I can use the less than operator. Greater than equal to, I can use the greater than equal to operator. In the same way, I can use less than or equal to operator. So all these are the logical, all these are the comparison operators, relational operators that we can use to check the relation between two variables, whether they are equal, whether they are not equal, whether they are greater than, whether they are less than, whether they are greater than equal to, whether they are less than or equal to. In order to perform all these operations, we can use these relational, or we can say comparison operators in Python as well. Now let us see the logical operators. Like I said, that if you want to combine two statements and check whether the conditions, whether the multiple conditions are true or not. So in order to combine two statements, basically logical operators are used. So in case of Python, we have the AND logical operator, OR logical operator and not logical operator. So these are the three logical operators. For example, AND returns true if both statements are true. Say for example, x less than 5 and x less than 10. So if the value of x is less than 5 and at the same time if the value of x is less than 10, then this statement will give me true. If x is greater than 5 and x is less than 10, if any one of the condition becomes false, so in that case it will give you a false value, that is a false Boolean value, that is the statement is not true. So AND will return true if both conditions meet the criteria. So in this case, the value of x should be less than 5 and again the value of x should be less than 10 only, then only this statement will give you a true value, otherwise it will give you a false value. That is by using the AND logical operators. Let us see OR operator. This is opposite of AND. So the OR operator returns true if one of the statement evaluates to true. It means what? If x is less than 5 or x is less than 4. So if either of these statement returns true, either of this statement is true, though in that case this statement, the condition or this logical operator will return a true value. Say for example, consider the value of x is 5 or the value of x is say 10. So in that case this statement will return a false. Why? Because I am checking the value of x should be less than 5 or it should be less than 4. So for example, if I am giving the value of x as say 1, so now this statement will give me a true value. Why? Because the value of x is 1. So, what I am checking here, that if x is less than 5 or x is less than 4. So, yes, it is not, it is less than, of course it is less than 4. So, the OR operator returns true if one of the statement is true. Not, this third logical operator is not. It will reverse the result, that is the return false if the result is true. So, if the result is true, then it returns false, and if the result is false, it returns true. So, for example, not x less than 5 and x less than 10. So, this will give me a false value if the statement is true. So, the not logical operator reverses the result, that is it returns false if the result is true. So, if the result is true, if the value of x is less than 5, then it returns false. So, it means that the value of x should not be less than 5, then only I will get a true value if I am using the not. So, the not will work in this way. Now, let us see the identity operator in Python, which is completely new for those who have learned the programming languages like C, C++ and Java. So, in Python we have the identity operators, for example, is and is not. So, here I am using the is when it returns true if both the variables are the same object. So, for example, if x is y, means what? If x and y are same, then it returns true. Means what? If x and y belongs to a same category of data type, then in that case it returns true. Is not means what? It returns true if both the variables are not belong to the same object, they belong to a different object. So, this is the opposite of is. Is will return true if both variables belongs to the same object. Is not will return true if both the variables does not belong to the same object. So, this is the identity operator. Like next is a membership operator. Membership operators returns true if a sequence within the specified value is present in the object. So, here I am checking that whether a value is found in a particular sequence or not. If a value is found in a particular sequence, then the in operator will return true. In, not in, that is the reverse of in. So, it returns true if a sequence with the specified value is not present in the object. So, in that case it returns true. So, in will return true if a sequence with a specified value is present in the object. Not in returns true if a sequence with a specified value is not present in the object. So, here I am finding whether a value is present in a specified sequence or not. If I have to find out, I will use in. If I do not have to find out, if I have to reverse it, that a particular value should not be found in a sequence, then I will use the not in membership operators. So, identity operators and membership operators are the additional operators which are included in Python programming language. Now, let us see the bitwise operators that you will find in all programming languages like C, C++, Java, etc. So, the bitwise operators will work on individual bits. The bitwise operators are used when we are writing a program which will interact with the machines. When you are dealing with zeros and ones, when you want to work on individual bits, then definitely I have to make use of bitwise operators. So, following are the bitwise operators, that is ampersand, we can say AND operator, the OR operator, the XOR operator, the NOT operator, the zero fill left shift and right shift. So, the AND operator sets each bit to 1 if both bits are 1. So, for example, if X will contain 1 and Y contains 1, then it returns true. In the same way, OR sets each bit to 1 if one of the two bits is 1, either X is 1 or Y is 1. In that case, the OR operator returns 1. Exclusive OR sets each bit to 1 if only one of two bits is 1. So, that is the difference between OR and XOR. The NOT operator inverts all the bits. If all the bits are zeros, then the NOT operator will make them as 1. If all the bits are 1, then it will make them as zeros. So, this is inverts all bits. Left shift, which will shift the bits by the number of position to the left. Right shift will shift the individual bits to the number of position that you specified with the right shift operator. So, these are the bitwise operators basically which are used to perform on individual bits. Now, let us come down to the event driven programming, which is one of the style of writing a program. We have object oriented programming, we have process oriented programming. In the same way, we have event driven programming. Basically, by the name you can identify that. What do you mean by event driven programming? Event driven programming are the programs which will driven by the events. Means what? Until and unless a event is triggered, your program is not going to execute. Until and unless the user presses a OK button or a submit button, nothing will happen. So, such a kind of functionality, if you want to bring in your programming, then you should use the style of programming that is called as event driven programming. Basically, in all Windows programming, you will find event driven programming. So, the flow of a program depends upon the events. The flow of program depends on the events. So, this is exactly opposite of process oriented. In case of process oriented, the process is already defined by the programmer. So, the flow program will execute in the sequence that the program has been written, in the sequence or in the flow that how the program has been written. In that way, all the code of the program will execute. That is in case of process oriented. But in case of event driven, the events, the program, the components of your program will execute based on the events. Say for example, I have a form, user registration form. In that I have different buttons. Say for example, previous button, I have next button, I have insert button, I have submit button and I have save button. So, here depending on the pressing of the button, that particular programming code will get executed. So, here I have pressed on the previous button. So, what happens here? The records which is stored previously will be displayed onto your screen. If I press on OK, then whatever changes that I have made in the present form will be saved. If I press on exit, then the program will get exited. So, here the execution flow of your program will depends on the events. They are triggered by the events. So, the flow of program depends upon the events, that is basically the opposite of a process oriented programming model like C and C++. They are process oriented, but whereas your Windows programming, VB.NET, all Windows programming are event driven, and programming which focuses events is called as event driven programming. And the working of event driven programming depends upon the events happening in a program. So, the components of your program will execute depending on which event is triggered by the user. So, the flow of program in case of event driven is not fixed. But in case of a process oriented programming, the flow of the program is already fixed. You cannot change in case of process oriented, but in case of event driven programming, the execution flow of a program is not fixed. It depends on the events, which event is triggered. Accordingly, its associated code will get executed. So, that is the basic difference between an event driven programming and process driven programming. Now, let us understand what are the local variables and global variables. The variables which are defined inside the block, inside a function, they are called as local variables, and the variables which are defined outside of all functions, they are called as global variables. But what is the use? What is the impact of defining a variable inside the block and defining the variable outside of all the blocks? So, if you define a variable inside a block, then we can access that variable only inside the block as long as the control is in that block only. Once the control exited that block, that function, then we cannot access that variable which is defined in that particular block. But on the contrary, if a variable is been defined outside of that block, then as long as the program is in running, we can access, we can refer the value of that variable which is called as a global variable. So, this is the basic difference between a global variable and a local variable. As you can see in the slide, how we can define the local variable. So, here def f, that is the function name is f. We define the functions in Python by using the keyword def. After that, we can specify the function name and parenthesis colon. What follows is the function definition. So, here in this function called as f, I have defined a variable called as s, and I have assigned the value is equal to praise the God. So, once you exit from this function f, you cannot access the value of the variable s. That is why, because I have declared the variable x inside the function. So, here this variable x is called as a local variable. So, in the same way, if I define the variable, as you can see in the slide, the variable s is been defined outside of the function s. So, now the s can be referred, it can be used even if I exit from the function f. As you can see in the slide as well, I can outside of the function f, I have returned the printf statement. So, here this function will give me the access to the variable s. Why? Because s is been defined outside of all functions, that is s is a global variable. Now, let us look at the buttons and input fields, that is the canvas. So, the canvas widgets displays various graphics on the application. It can be used to draw simple shapes to complicated graphs, as we can display various kinds of custom widgets according to our needs requirements. We can create buttons on a canvas widgets. Firstly, create canvas, then place the buttons on the canvas. So, first create the canvas, after that create the button and place the button on the canvas. So, this is the syntax of how to create the widgets and place onto the canvas. So, for example, C is equal to, that is the name of the variable, is equal to canvas. I am creating a canvas by specifying, by providing the attributes like root, comma height, width, that is BD and BG. So, here with the syntax button is equal to, if I have to create a button, then how it can be created? With the use of following syntax like button, that is the name of the button, is equal to button is the name of the function. In the bracket, I need to provide the attributes such as the root, that is the reference of my window. I have to specify the height, width, the background color and the comma ND as well. So, here I have created the object of canvas and the object of button. So, now what are the steps? The first step is to import the TK inter from the library, then define the window size and other requirements as well. First, create the canvas from the above given syntax, that is C is equal to canvas, and provide the appropriate attributes, and with the help of the place button in the TK inter library, place the buttons on the canvas. Now, let us see how to perform the static drawings and timers. So, how to create a countdown application by using Python? The code will take input from the user regarding the length of the countdown, regarding the length of the time in the seconds, and after that a countdown begins on the screen in the format of minutes and seconds, and we will use the timeout module here, and in this we will be using the time module and its sleep function to follow the below steps to create a time down application in Python. So, the first step is to import the time module. Second step, then ask the user to input the length of the countdown in the seconds. Third step will be this value is sent as a parameter t to the user defined function countdown, and any variable read using the input function is a string. So, we need to convert. So, whatever value the user will input through keyboard will be treated as a string. So, here I need to convert that string into a number. So, convert this string to the integer as it is of string type. Step number 4, in this function a while loop will run until the countdown time becomes 0. Step number 5, use the div mode function to calculate the number of minutes and seconds. Step number 6, now print the minutes and seconds on the screen using the variable time format. Step number 7, using the end is equal to the \r, we force the cursor to go back to the start of the screen, that is the carriage return, that is \r will work as a carriage return, so that the next line printed will be overwritten on the previous one. Step number 8 will be the time.sleep function, which is used to make the code to wait for 1 seconds. Step number 9, now decrement the time so that the while loop will come to end after some time. Step number 10, after the completion of the while loop, we will print the fire in the hole to signify the end of the countdown. So, in this way here we can create a countdown application. So, this is the code that you can see in this slide, that is importing the time module from the time, import time, then define the countdown function, that is def countdown t, specifying the while loop. In that we have defined the minutes, seconds, and we have called the div mode function providing the parameters, that is t, 60. Timer is equal to, we have defined the format. After that we are displaying the time after every seconds, and after that we have decrementing the time so that the while loop comes to end after executing the number of times that the user has been given the input value. So, once the while loop will exit, I will print the message as the last statement, that is the fire in the hole will be printed. So, this is a simple example of a countdown application. Countdown, we can say timer. Now, let us see the control statements. What are the control statements and what is their use? Control statements in Python are used to manage the flow of your program by making decisions. The control statements are used to make decisions. The control statements are used to execute the statements multiple number of times. So, for conditional statements we have the if statements and elif statements. So if you want to check whether a statement is true or not, I can use the if statement. So the if statements are used for decision making and they execute a block of statement if a certain condition is true. Elif statements, elif, that is the short for else if is used to specify multiple conditions. If the first condition is false, it will check the next else if condition. So if you want to check multiple conditions, then I can go and use the else if. So for example, if I have to display the grade of a student, then what I will do here, if the grade is less than 70%, then I will, or say if the grade is greater than 70%, I will display as say distinction. Else if, I will say as the first class. So if you want to check multiple conditions, then I will use the if and elif conditional statements. And if you want to execute a single statement multiple number of times, if you want to repeat a statement multiple number of times, I will go and use the for loops. The for loops are used to iterate over a sequence. For example, a list, a tuple or a string or any iterable object. So if you want to repeat a bunch of statements n number of times, then I will use the for loop or I can use the while loop as well. So in the same way, we have the break statement and continue statements as well. The break statement is used to exit a loop prematurely even if the loop condition is true. So if you want to exit from the loop prematurely, I can use the break statement, and continue statement is used to skip the current iteration and it will move to the next iteration of a loop. So if you want to skip a statement for a particular iteration, then I will use the continue statement so that the control will be transferred to the next iteration. So break, continue are again the conditional statements, which are used. The break is used to prematurely exit from the loop, whereas continue is used to skip a particular iteration. So this is the use of break and continue. Now let us look at the functions. Functions are fundamentals to any programming languages, be it Java, be it C++, be it Python. You take any programming language, functions are fundamentals, building blocks of any programming language, and they help make your code modular, reusable and easier to understand. So the advantage of functions is they will make your entire program as modular, as readable and as reusable. So without the concept of functions, no programming language is complete. So functions are the fundamental building blocks of any programming language. Now how we can define a function? So if you want to define a function using in Python, we have to use the keyword def. So def keyword is used to define a function, followed by the name of the function and a pair of parentheses, and you can also include the parameters, that is the input variables inside the parentheses if the function needs to accept some values from the user or from the caller of the function. So the function's code block is indented below the def statements. Now how to call a function? To use a function, you call it by its name and provide the required arguments if that function accepts any parameters within the parameters. How the function's body will be displayed? So that is function anatomy. So the function name should be a descriptive name. It should be, always remember that the function name should be a descriptive one. It is meaningful name that follows the Python's naming conventions, that it should be given in a lowercase with underscores for multiple words. Parameters, these are the optional input that a function can accept, and parameters are like variables that receive values when the function is called. So, what are the different parts of a function? A function having a function name, the parenthesis, the parameter list as well. So, these are the different parts of elements of a function, that is function name, the parameters list and the parenthesis. Now, let us talk about the function body. The block of code within the function that perform the desired task is called as the function body, and this code is indented under the def statement. So, in Python we do not have a curly braces or any other braces to define the block of a function. So, what we use, we indent. Indentation is very important in Python. So, the code is indented under the def statement and the return statement, and it is used to send a value back to the caller, and a function can return a single value or multiple values as a tuple. So, this is all about the functions. Now, let us look at the some of the OOPS concept, that is the OOPS is the programming style, that is object oriented programming style. Like I said, there are different styles of writing a program. It could be process oriented, it could be event driven, or even it could be object oriented programming that a C++ follows. So, OOPS programming is a programming style that is widely used in Python and many other programming languages, and is based on the concept of objects. So, everything in OOPS is considered as objects, which represents the real world entities and the interactions between these objects, these real world objects. So, here are the key concepts of OOPS, that is using Python. So, even in Python we are using the concepts of OOPS, that is the like inheritance, the encapsulation, the object and classes as well. So, first the concept of OOPS is a class, and a class is a template, a class is a design for constructing the object, a class is a blueprint. It specifies the class objects characteristics, what are the data members and what are the functions that make up a class. So, Python classes are defined with the class. So, class, say for example, if I have to define a class in Python, I will define like class dog colon function underscore underscore init underscore underscore self comma name comma breed. So, this is if I have to define a class, then the keyword is class, specify the class name, after that the colon, then what follows is the functions, the data members of a class. So, here as you can see in the slide, function underscore underscore init underscore underscore self comma name comma breed. So, this is what this is called as a constructor. So, here I have defined a class called as dog, and here I have initialized the object, the data members of the class called as dog, as you can see, and again I have defined one function which belongs to this class called as dog, like def bark. So, here the class called as dog consists of one constructor and a method that is called as bark. So, in this way you can define a class in Python. A class is instance. So, once a class is been created, we can create n number of objects. So, for example, if you create a class called as fruit, then I can create n number of objects of that class called as fruit. Means what? I can create an object like mango, I can create an object like banana, I can create an object like oranges, etc. Again, if I have created the class called as say bird, I can create the object of the class bird as sparrow, as crow, etc. So, an object is an instance of a class. So, once a class is created, we can create n number of objects from that class. So, we can say that a class is a logical entity, whereas the objects are the reality. So, objects will actually contains the data members and functions. Class will only define its blueprint. Class will only define the what are the members, what are the data members, what are the functions of a class. So it's like a drawing, it's like a map, it's like a blueprint which is present only on paper. But until and unless you create an object of that class, the functionality of that class will not come into existence. So objects are the reality, whereas class is a logical entity. So objects are real entities and the class is a logical entity. So here how we can create, once the class is been created, we can create the object like a dog following in the following way, like canine1 is equal to dog, that is the name of the class called as dog, and we can specify the parameters as buddy, comma golden retriever. So here I have created the object of class called as dog with the name of canine1. Again I can create another object like that is canine2, that is as Max, comma German Shepherd. So in this way, once the class has been defined, you can create a number of objects from that class. So that is the beauty of creating a class. Encapsulation. Encapsulation is the concept of binding the data and methods that operates on that data into a single unit called as class. So when you create the object of a class, so definitely you are achieving encapsulation. Means what? What object will contain? The object contains the data and the method which operates on that data. So the object and the functions, the method are encapsulated together, they are binded together, they are encapsulated together, they are called as an object. So encapsulation is the concept of bundling the data and its method which operates on that data into a single unit. So object is a single unit. So what object will contain? The object will contain the data plus its functions together in a single unit. So when you create the object of a class, you are creating, you are achieving the concept of encapsulation. Inheritance is the mechanism that allows you to create a new class from the existing class. So the main advantage of inheritance is reusability. Once the class is been created, you can inherit that class into another class. So you can create another class without directly changing the attributes of a class, isn't it? Say for example, I have created a class called as say a fruit. So from fruit class I can create another class called as say vegetables. So here what happens here? The data members of a class called as fruit which are already created, they are already comes into my new class called as vegetables. I don't need to redefine them in my new class. So without directly making changes into the existing class, I can create a new class, that is called as reusability. So inheritance is a mechanism that allows you to create a new class from the existing class. So when you inherit the existing class into a new class, you inherit all or some of the methods, the data members of the existing class into a new class. That is called as inheritance. So inheritance, class, encapsulation, all these are the concepts of object oriented programming language. Next is a polymorphism. Polymorphism means what? Polymorphism allows objects of different classes to be treated as the object of a common base class. It allows you to use a single inheritance for a different purpose. The best example of polymorphism is the plus operator. So for example, the plus operator performs multiple tasks based on the input value that you provide. So for example, if I provide two numbers to the plus operator, what the plus operator will do? The plus operator will give me the sum of two numbers. For example, if I have given 20 and 10, what is the result? That is 30. But on the contrary, if I provide input as say character A into single quotes and character B into single quotes, character A and character B. I have given these two inputs to a plus operator. What plus operator will do? The plus operator will now concatenate these two characters. What is the result? The result is string, that is AB. So, depending on the input values, the plus operator performs multiple tasks. So, polymorphism means what? One name which performs multiple tasks depending on the input. Best example that I have given as the plus operator. If you provide numbers, it will give you the addition of two numbers. If you provide two characters, it will concatenate. So, polymorphism, one name performs multiple tasks depending on the values that you provide. It is called as polymorphism. So, we have compile time polymorphism and runtime polymorphism as well. So, this is the example. Just go through this example. Next is abstraction. So, abstraction hides the complex implementation details and shows only relevant object features. It simplifies the object interaction. So, what is abstraction? Abstraction is giving the important features without giving the details. Say for example, best example is the switchboard in your house. What it tells? When you push the switch, the lights will blow up, and again when you switch the same switch, the light will go off. So, pushing the switch will lights come up, and again pushing the switches, the light will go off. So, this is the important functionality which has been given to the user, but the internal functionality, the internal details, the internal wiring is not been given to the user. So, that is called as abstraction, giving the important details, but at the same time not giving the internal details. The internal details are for the programmers. What user requires? User requires only the functionality. User need not know the internal details of that particular application or of that particular product. That is called as abstraction. So, abstraction, encapsulation, inheritance, class, objects, all these are the main concepts of object programming language. Now, let us come down to the constructor and destructors. Like I said that constructors are used to create the object, constructors are used to initialize the object, whereas the destructors are used to delete the object from the memory. So, as soon as your work is over, you need to give the resources back to the environment. So, for that I need to use the destructor. So, the destructor will destroy the object, whereas the constructor will construct the object. Means what? It will provide the initial values to your objects. That is the work of constructor. And destructor, once your work is over, that object needs to be destroyed, otherwise the memory is wasted. So, here destructor will release the memory and constructor will allocate the memory or initialize the objects, initialize the values to the data members. As you can see in this slide that how the constructors has been created. You can see here class, name of the class is my class colon, after that I have defined a constructor with the keyword def underscore underscore init underscore underscore, in the parenthesis I have specified as self, again the colon. So, this is how a constructor will work. So, when you create the object of this class called as my class, the init constructor will automatically get executed. We do not need to call a constructor. Constructors are automatically called whenever you create the object of a particular class. Now, let us come down to the exception handling. What is exception handling? Exception handling in Python is a mechanism that allows you to handle and manage the unexpected errors or the situation, the errors which comes at the runtime, they are called as exceptions. So there are two types of errors. One, the error which comes at compile time, they are called as compile time errors, and the errors which comes when your program is actually running, they are called as exceptions. Say for example, divide by 0 is an exception which comes when your program is actually running. File not found is an exception which comes when your program is actually running. Okay. Syntactical errors are compile time errors, but divide by 0, file not found, class not found, these are exceptions. So exception handling is again very important. We need to handle the exception so that our program execution will smoothly run through all the code of my program, even though if I encounters an exception. See that if you don't handle the exception, what happens? Your program abruptly exited, your program abruptly halts. But if you handle the exceptions, so even if the exception arises in your program, the execution of your program will continue, or at least it will handle that exception so that the user will come to know that I have encountered an exception. So there are some advantages of handling the exception. One is to avoid the abruptly exited, abruptly stopping of your program, and the second, that we can handle the exception so that we can make our program execution smoothly. How the exceptions are handled in Python? They are handled by the keyword try. In the try block, we write the statements for which I suspect that the error will come. Say for example, if I write a is equal to 10 by 0, so definitely the exception, that is divide by 0, will come here. I know this, but this is a simple example I have given here. For the statement for which you suspect that the exception can occur due to this statement, what I will do? I will write this statement in a try block, and in except block, what I will do? I will write the code to handle that error, to handle that exception. If the divide by 0 exception occurs, it will be thrown. I will catch that exception in the except block, and I will write the code to handle that exception. Means what? What should happen next when divide by 0 exception occurs? That code I will write in the except block. In finally block I will write the code which will executed in matter whether exception occurs or exception does not occur. So for example, the cleaning up of activities, cleaning up of memory, giving the resources back to the environment, all such codes, cleaning up activity codes are being written in the finally block. Why finally block? Because the code that you write inside the finally block will get executed anytime whether an exception comes, whether it is been handled, whether it is been not handled. So the code inside the finally block will always get executed. So I will write the cleaning up of activities in finally block, and the raise block, in the raise block I can raise this statement, I can throw the exception by using the raise block. So the raise statement is used to explicitly raise an exception. So I can explicitly raise the exception, or even some exceptions are being raised by the system as well. If I have to raise the exception by myself, I can raise that exception by using the raise statement. So the raise statement is used to explicitly raise an exception, and you can raise the built-in exception or create your own exceptions, own custom exceptions by inheriting from the exception class as well. So this is the example of how we can handle the exceptions in Python. Just go through the code. The code is self-explanatory as well. Now let's come down to the file handling in Python. Python's file handling is essential for reading and writing to your computer's files to your file system, and Python built-in functions and methods make file operations easy. So Python will provide you the built-in functions by which I can perform the file operation, that is reading from file, writing to a file, deleting a file or modifying a file. For all these operations, Python provides the built-in functions. So, opening and closing of files, how to open and how to close the files. Use the open function and use the close function to work with a file. If you want to open a file, we have to use the open and we have to provide the required parameters, and if you want to close a file, you can simply call the close function as well. So, this is the syntax of how to handle the file, that is file is equal to open function, specify the file name and specify the mode. If you want to open for read, then you have to use the R. If you want to open it for writing, you can use the W as a mode. So, these are the syntax to open the file and to close the file. If you want to close the file, just specify the object of file, that is file dot close the function. And if you want to read from a file, you can read the content of a file using various methods such as the read line or read lines or read. So, the read function reads the entire content of the file as a single string. So, here we can make use of different read functions, that is we can use read, we can use read line or we can use as read lines as well. So, this is the example, that is file is equal to open function, specify the file name, specify the mode, that is I have opened the function, opened the file for reading purpose. Now, I am reading from the file and I am storing that content into a content variable like content is equal to file dot read. After that, I want to print whatever I have read from the file example dot txt and from the content variable by using the print function. After that, I have finished reading, then I have to close the file by using its object called as file dot close in this example. So, read line reads one line at a time and you can iterate through the lines in a loop. So, read line will read a single line at a time, and if you want to read all the lines of the file and return them as a single list, then I can use the read lines as well. The code for the both for read line and for reading reading the entire line in entire file is been given in the slide as well. Just go through it. If you want to write to a file, you can write the data to a file using the write function or write method, or if you want to append data to an existing file, you can use the mode as append. So, writing to a file, again first we need to open the file by using the open function. After that, by using the write function, we can write to a file by specifying the name of the object of the file, in this case that is file dot write, and the parenthesis I want to write hello world. So, here I have written the hello world as a string. After that, I have to close the file as by using the object name of file, that is file dot close. So, this will close the file which is opened for writing purpose, and if you want to append to the existing file, then you have to open the file in the append mode. So, here I have opened the file in append mode, as you can see. After that, I can write as by using the file dot write, and I can provide the string in a double quotes. After that, I am closing the file, that is file dot close. So, this will write, this is how we can write to a file, and this is how we can append to a file as well. So, now using with this statement, that is context managers, a more elegant and safer way to work with files is by using the with statement as a context manager. So, it automatically handles the opening and closing of the file for you. So, by using the with statement, what is the advantage? The advantage is that it automatically handles the opening and closing of the files for the users or for the programmers, even if an exception occurs during the operation. So, with the keyword, I am opening the file example.txt in R mode as file. Now, I am reading the content by using the read function and storing the content into the content variable, and after that by using the print function, I am displaying the content of the example.txt. So, here a file is automatically closed when exiting the with block. So, here I do not need to close the file. Even if the exception occurs, the context manager will take care of closing the file. So, that is the main advantage of using the with statement with files. Now, opening the file in a binary mode, that is binary files and modes. How we can work in a binary mode? In addition to the text files, Python can handle the binary files such as the images or audio files as well. And by using the modes like RB, that is read binary, and WB, that is write binary, I can work with the binary files as well if I have to work with the images or the audio files as well. So, with open, specify the file name and mode as RB, that is read binary, as file name. Now, I am reading binary underscore data is equal to bin underscore file dot read. So, the content of binary file dot jpg will be stored into the variable called as binary underscore data. So, now this is how I can read from a binary file if I am dealing with images or if I am dealing with the audio files as well. If you want to write to a binary file to a file with the function with open, specify the file name, and now we can say here the mode as write binary, as file name new underscore bin underscore file, new underscore bin underscore file dot write, specify the content that you want to write to the binary file. So, with WB we can write a binary file, and with RB I can write the binary file, I can read the binary file from the file. So, with this come to the end of this session. I hope you have enjoyed this session. Thank you for watching.